Hello viewers, welcome to Civil Engineering Shiloh's Updates. Today we are going to learn concrete mix design calculation step-by-step procedure with example as per IS 10262 2009 Codebook. Steps. There are 7 steps to calculate mix design. What are all the steps? Target mean strength for mix proportioning, selection of water-cement ratio, selection of water content, calculation of cement content, proportion of volume of coarse aggregate and fine aggregate, mix calculations and mix proportions. Design mix of M40 as per IS 10262 2009. Test data to calculate mix design for M40 grade. Cement used OPC 43 grade. Maximum nominal size of aggregate 20 mm. Maximum water cement ratio 0.45. Degree of quality control good. Type of exposure severe. Workability 100 mm slump. Minimum cement content 320 kg per meter cube. Type of aggregate crust angular aggregate. Specific gravity of cement 3.15, specific gravity of coarse aggregate 2.74, specific gravity of fine aggregate 2.74, water absorption of coarse aggregate 0.5%, water absorption of fine aggregate 1.0%, surface moisture of coarse aggregate 0%, surface moisture of fine aggregate 0%, bulk density of cement 1440 kg per meter cube, bulk density of coarse aggregate 1650 kg per meter cube, bulk density of fine aggregate 1800 kg per meter cube. Step 1. Target mean strength for mix proportioning. F-CK equal to FCK plus 1.65 into S, where F-CK is target average compressive strength at 28 days, FCK characteristic compressive strength at 28 days, S standard deviation. FCK 40 Newton per mm square, S 5 Newton per mm square. Now substitute those values, we get the answer F-CK equal 40 plus 1.65 into 5. Now let me clear you how this value 5 came here. This value. You can take this value standard deviation from either of two code books. That is from IS 456-2000, page number 23, table number 8, or from IS 10262-2009, page number 2, table number 1. Now when we solve this, we get the answer 48.25 Newton per mm square or megapascal. I have shown the standard deviation values in 2 core books also. In IS 456-2000, Table 8. In IS 10262-2009, Table 1. There you can see for grade of concrete M40, assumed standard deviation they have given us 5.0. Similarly, in Table 1 also, for grade of concrete M40, assumed standard deviation is 5.0. In this way, you have to take the value of standard deviation. Step 2. Selection of water-cement ratio. From Table 5 of IS 456-2000, for severe exposure condition and for aggregate size 20 mm, maximum water-cement ratio is 0.45. But based on experience, use water-cement ratio as 0.40, which is less than 0.45. Hence, OK. Now refer page number 20 of Table 5 from IS 456-2000. In this code book, you can see for severe exposure condition and for aggregates of 20 mm nominal maximum size, the maximum free water cement ratio is 0.45. This is how we have to take the value of water cement ratio. Step 3. Selection of water content. For this, refer page number 3, table number 2 of IS 10262-2009. In this table 2, for nominal maximum size of aggregate 20 mm, maximum water content is 186 liter. But this 186 liter is for only 25 mm to 50 mm slump range. But our workability slump value is 100 mm. Now refer page number 2 in IS 10262-2009. In that, for the desired workability other than 25 to 50 mm slump range, the required water content may be established by trial or an increase by about 3% for every additional 25 mm slump. Therefore, for every additional 25 mm slump, 3% can be increased to find water content. So, in this design mix, 6% can be increased because 100 mm is our slump value. Therefore, estimated water content for 100 mm slump is equal to 186 plus 6 upon 100 into 186, which is equal to 197 liter. Note: if superplasticizer is used as an admixture, water content can be reduced up to 20%. Step 4. Calculation of cement content. We know that water cement ratio is 0.40. Therefore, water cement ratio is equal to weight of water, that is water content, upon weight of cement, that is cement content. Now substitute the values. 0.40 equal to 197 liter, which is water content, upon cement content. Therefore, cement content is equal to 197 liter upon 0.40. The answer is 493 kilogram per meter cube, which is greater than 320 kilogram per meter cube. How this value 320 kilogram per meter cube came here? You can refer this value in table 5 of IS 456-2000. In that they have given the minimum cement content for severe exposure condition as 320 kilogram per meter cube. Now this calculation is okay. Step 5. Proportion of volume of coarse aggregate and fine aggregate. For this, refer table number 3 of IS 10262-2009, page number 3. Here 4 zones are there. Zone 1, Zone 2, Zone 3, Zone 4. In that, Zone 1 and 2 is for concreting. We have nominal maximum size of aggregate as 20 mm. So, for Zone 1, the volume of coarse aggregate value is 0.60. Note, for pumpable concrete, these values should be reduced by 10%. Volume of fine aggregate is equal to volume of concrete minus volume of coarse aggregate is equal to 1 minus 0.60 is equal to 0.4. Step 6. Mix calculations. Volume of concrete is equal to 1 cubic meter. Volume of cement is equal to mass of cement upon specific gravity of cement into 1 divided by 1000. Now substitute the values. 493 upon 3.15 into 1 divided by 1000. So we get the value 0.156 meter cube. Volume of water. Mass of water upon specific gravity of water into 1 divided by 1000. Now substitute those values. 197 upon 1 into 1 divided by 1000. So we get the answer 0.197 meter cube. Volume of all in aggregate, that is volume of concrete, cement and water, is equal to A minus B plus C, which is equal to 1 minus 0.156 plus 0.197. So we get the answer 0.647 meter cube. Mass of coarse aggregate is equal to E into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. E value is 0.647, volume of coarse aggregate is 0.60, specific gravity of coarse aggregate is 2.74 and 1000. So we get the answer 1064 kg. Mass of fine aggregate. E into volume of fine aggregate into specific gravity of fine aggregate into 1000, which is equal to 0.647 into 0.4 into 2.74 into 1000. So we get the answer 709 kg. Step 7. Mix proportions. Cement 493 kg, fine aggregate 709 kg, coarse aggregate 1064 kg, water 197 liter, water cement ratio 0.40. Now the results are cement is equal to 1, fine aggregate is equal to 709 upon 493. So we get the answer 1.44. Coarse aggregate is equal to 1064 upon 493. So we get the answer 2.16. The mixed proportion for M40 concrete using given specifications is 1:1.44:2.16. If superplasticizer is used as an admixture, then volume of chemical admixture is equal to mass of chemical admixture upon specific gravity admixture into 1 divided by 1000. If you like this video, kindly do subscribe, click the bell icon, share this video, and do support my channel Civil Engineering Shylus Updates. If you have any query, mail me at shilusupdates@gmail.com. Thank you.